Welcome to today's session, everyone. Thanks for joining us. Assume y'all are all getting settled. My name is Amanda Henley. Glad to have you here for today's virtual CICS user group session. We've got the chat open. If at any time I become gargled from my internet connection, I'll cut my video, but I want to go ahead and get us started so that Drew and Andrew have plenty of time to present for us today. Again, thank you for coming. This is our user group session for CICS. We all have DB2 and IMS, and those are available in alternating months. So check those out at virtualusergroups.com. Today, we have our presentation. We're going to do some Q&A afterwards. We'll talk about any news or articles that have come out that you should keep an eye on, and I'll give you the date for our next session. So with that, we can go ahead, and I want to thank our partners. Broadcom and Data Kinetics are our sponsors for this user group series. We have availability if you know of a company that should partner that might want to occasionally share some of their own expert insights as well. You can reach out to me. I'm easy to find, Amanda@planetmainframe.com. We will be at Share next month. I'm really excited to be there. And Share's a fun show. We've got a lot of really fun stuff that Benny and I were planning for our next booth at Share. So I hope to see you there. That's where we'll kick off our influential mainframer nominations. So keep an eye out for that. And we'll also release the 2025 Arcadi Mainframe Navigator. There'll be lots of fun prizes too. After today's session, we have a very quick exit survey. It's 2 questions, just as you're leaving and exiting out, you can just press the answers. It's basically what you thought about today's session. So we'd love your feedback. And then for Q&A today, you can leave your questions in the chat and we'll be answering them in real time. So Drew and Andrew both are going to be presenting today. And one will be able to monitor our chat while the other is presenting. So it'll be a great opportunity for you to get your questions answered. And then I'm sure we'll have a little bit of time at the end if anyone needs to come off mute or has anything more in depth they'd like to talk about. Now I'm going to stop my screen share so that our presenters can start theirs. And I'll tell you a little bit about our presenters if I can pull up my notes. So our session today is by Drew Hughes and Andrew Twydell. Drew is developer on the CICS Modernization team, working on a variety of products in the CICS portfolio, including CICS Ansible Collection, CICS Explorer, and the CICS Bundle plugins. And Andrew is a software engineer in the CICS Modernization team at IBM. He focuses on ZOS and CICS technologies and does other innovative projects within the mainframe ecosystem. So with that, I'm going to turn it over to you and let you just take it away.
Awesome. Thank you very much. That explanation makes my job sound very exciting. So thanks for that. So yes, Drew and I here, we're going to talk through Ansible Automation Platform in action and how we can use some existing collections to provision CICS and interact with it using Ansible playbooks. But first, we're going to talk a little bit over the Ansible basics. So there are people that might know what Ansible is on the call. There are people that might not know what Ansible is. So we're just going to do a very quick dive into what it is. So Ansible it's an automation technology. It's an industry standard configuration as code tool used for automation. Their tagline, I've put it in the screen here, is turning tough tasks into repeatable playbooks. So anything that is tedious, that you're doing manually, or tasks that you have to do over and over again, Ansible is a great option to automate those. It allows for configuration or management of systems, and you can actually target multiple systems at once as well. So we're going to do a demo that targets no, we're not. Sorry. No, we're not. But yes, Ansible allows you to, if you're making changes to multiple systems and those changes are going to be the same, you can perform those changes in parallel, which is a big time saver. So some common uses for Ansible, although by no means is it confined to these tasks. System provisioning is a great example. We're going to look at that shortly. So bringing up systems and taking systems back down in an automated way. Installing applications, it actually pairs nicely with the first example there as well. Installing applications into systems so that they're ready to be used. This could be in a self-service manner, so a developer could provision their own system with applications already installed. And then once again, bring them back down again when they're finished, all automated. That means it's reliable and repeatable, so you don't have a clash of environments, or you do config slightly wrong and then the environment isn't brought up in the same way. Managing users and updating certificates, tasks like that can be tedious and repeated. A lot of the time you're doing the same thing. So if you're managing a user, it's going to be the same action that, regardless of the user. Automating that kind of thing with a playbook is a great example of where it can be used. And Ansible doesn't have to be a manual process either. So CI/CD pipelines are a great way to use Ansible as part of your automation. You can pick specific parts of your pipelines and use Ansible there. It's a good way to sort of gradually adopt Ansible rather than going all in. So what makes Ansible so popular? So it's a really good way to standardize your automation tooling across your organization. It's very likely somewhere in your org, Ansible is already being used, because it's easy to pick up. And as I said, you can do little pieces of automation with it, and sort of build up your collection as you go. It can also be used on lots of different platforms. So we're going to be targeting z/OS today, but it works against Linux. It works on your local machine, which means it's one tool to be used across your entire infrastructure. It can also be used against network switches, which I always think is a nice fact. If your network switch allows SSH. There's a lot of existing expertise when it comes to Ansible because of its popularity, which means finding people that that know how to do it, and the documentation and the help in the community is easy to find. And it's extensible. So if you're trying to do something that Ansible can't do easily or nicely, you can create something yourself. You can develop your own or build up your own playbooks to do a task and share them amongst your organization as well. But I mean, the biggest winner is its configuration as code actually realized. So if you want to store your infrastructure as code and your configuration as code in some kind of source control like Git, Ansible allows you to do that. And that means you can reliably bring up and down your infrastructure and manage it with history. So it works via SSH. That's not always true, but the majority of the time it is an SSH protocol that you need. So on your control node, which is where you're running your Ansible from, today that's going to be my laptop and Drew's laptop, or Ansible Automation Platform, which we'll come on to. That is your controller, and that is where you're triggering the automation. And then your managed node, or the system you're automating, or systems you're automating. In our case, that's going to be either your laptop again or a z/OS system that we're pointing to. And it's SSH that handles that connection. It ships little packets of Python code over to your managed node, executes them, and gets a response back. So we're going to jump straight into a demo of showing how you can build up an Ansible playbook. It's going to be a very, very simple playbook. to start off with, but I'm hoping you can now see VS Code. Cool. So a playbook is the list of tasks that Ansible is going to perform. It's written in YAML, so a .yml or .yaml file extension. And you start by giving your playbook a name. So Ansible 101. You then need to say, this piece of automation, where am I going to run it? For this first example, we're going to run it on localhost. So that means this piece of automation is going to run on my laptop. And finally, what we'll do is put a list of tasks, so things to perform. So each task also has a name. So we're going to do create a file, nice and simple. And you can see if I do Ansible.builtin. You can see all of these tasks that are pre-built into Ansible. So all of these do a specific thing. And I'm not going to go through each and every one. We're going to pick Ansible built-in file because we are creating a file. So it gives me some nice options that I can use here. We're going to start by giving it a path, so where we want to create the file. And we're going to put it alongside the playbook. So playbook directory being the directory the playbook lives. We are going to give it a mode, so the permissions that we want set. You can also hover over these and it gives you nice syntax, nice descriptions of what those are. And we're finally going to give it a state. So a state is, this just gives you all the options. So this is the state in which the file will be. So absent will make sure the file does not exist. We're going to use touch, so we're going to create the file. I'm now going to go down to the terminal, do Ansible playbook, and give it my playbook name. And it's going to run through, create a file, and there it is. We've created a file, we've run a playbook. We can now change the state to absent and run it again. And we will delete it. So we have just built up our first playbook. Now, what if you want to do this on ZOS? You have to tell it where to run that's not localhost. So that's where inventories come in. So I've got an inventory file here. An inventory is a list of hosts that you want to target. And this is where you could specify multiple if you wanted to run this against multiple systems at the same time. I've got one host in here called ZOS, and I've given it some standard information like the host, my user, and then some environment variables that are required to run some of the ZOS collections. They're not too important though, we can touch on those a bit later. This is important though, the name of the host. So in our playbook, rather than running it against localhost, we'll run it on ZOS. And we will create a file under my user group, hello world. We also need to give it those environment variables I said about, the environment vars, and provide the inventory in our CLI command. Now, presuming I've not missed anything, which is possible, we will create a file. Now, I'm going to switch over to this Zoe Explorer view here to list files under Twydell user group. Aha, state is absent. Well done to anybody who spotted that. I will run it again with state as touch. And if I refresh, there is our file. Fantastic. Cool. So now we're running on ZOS. However, Ansible doesn't have built-in support for creating datasets. So what if we want to create a dataset? We're going to do create a dataset, and we're going to use a collection. Now, collections are the way you extend Ansible, and there is a collection called This is loading. Being very slow. Just going to reload the window. Apologies. There we go. So it's IBM ZOS core dot, and then they have a lot of functionality that can interact with things on ZOS. We're going to use IBM ZOS core dot ZOS dataset. So it creates, deletes, and sets attributes of datasets. So we're going to use it to create one. So we're going to do Twydell dot user group dot something dot hello. We're going to give it a dataset type of sequential. And we're going to give it a state of present. So we want this dataset to be present and we want it to be a sequential. Let's run it again. And we have passed. I refresh the view, and there is our dataset. Again, one more. I'm going to change the state to absent, run it, and it will delete it. So using this collection, you can interact with ZOS resources. They have a bunch that I'm not going to go through. I could populate the dataset, but I don't want to go over time, so we will switch back. So there is a growing set of collections for ZOS on Ansible Galaxy. And Ansible Galaxy, that's the repository where Ansible collections live. I like to compare it to Java having Maven Central or Node.js having NPM, Node Package Manager. Ansible has Ansible Galaxy. So this is IBM ZOS core collection, gives you, foundational experience on datasets, APF, transferring data, operator commands, that kind of thing. They're also part of the Red Hat Ansible certified content for IBM Z. So that means they're also available on Ansible Automation Platform, which we're about to look at, as well as some other collections on the right-hand side here, including IBM ZOS CICS. Couple of key terms that we've just spoken about. So Ansible, that's the tool that we've just used. It's the runtime that executes the automation driven by a Ansible playbook CLI. And that playbook is the list of tasks written in YAML that you want to implement. A collection, that's the extension to Ansible. And you install it from Ansible Galaxy, which is that online repository of those extensions and collections. So, talking about CICS, what can we use Ansible for in a CICS world? So, the CICS collection for Ansible is split into two, really, but it gives you ability to interact with CMCI to get CSD resources and manage those, as well as CICS provisioning. So we're going to talk about it in two separate worlds. So it is being developed in the open source. So that is the link on GitHub there, and it's available to download on Ansible Galaxy there. The CICS collection is also part of that Ansible certified content for Z. So the first half is the CICS CMCI tasks. They're available in all versions on this, less than this 2.1, which will be clarified later by Drew when he talks about more than or equal to 2.1. And they use CMCI on the target nodes, so on ZOS. So picture this in a land far, far away. A system programmer needs to capture the state of some CICS resources, maybe to compile into a report or, daily take a snapshot of the regions or something like that. This is possible through CICS Explorer, but it would be, dreadfully slow manual process of searching and getting the right data out. So let's try and automate this using Ansible. And this is actually one of the samples in our samples repository. So we're going to jump over there very quickly here. So this is our samples repository. That gives samples on how to do certain things. CMCI, I'm going to go through this reporting sample, but there are plenty of others about deploying programs, restarting bundles, that kind of thing. But the reporting sample looks something like this. So again, this is a playbook. We've given it a name. We're telling it to run on localhost. We're then prompting for variables to use. So this is like an interactive playbook where it'll ask you for the host and port and things like that you want to run it against, rather than using an inventory for variables. These are the attributes that we want to pull from CMCI. And we go down, and our tasks include installing some dependencies so that the playbook can run, actually calling this IBM CICS CMCI get task to get some information, and then we provide all of our values provided by the user. And the resource type we're pulling is CICS region. Then we format it into a template and we output a report.csv file. So I'm going to run this report.yaml. It's going to prompt me for my information. So I've defaulted everything for me so I don't have to type it live and embarrass myself. But host, port, scheme. So information about the host. The CPSM context. So in this case, I'm querying a specific plex. And then username and password. And what that'll do is it'll install dependencies, pull from CMCI, and create this CSV report, which has now appeared. And this is information about our CICS regions with the attributes that we specified. So thinking about doing that with CICS Explorer as an example of another tool we could use, that would take a little while, maybe not hours, but longer than running that playbook. And we can go and we can say, okay, I also want the SysID for those regions as well. Run it again. And our report.csv will update with this. Oh, sorry, I need to provide all my information. And the SysID will also be pulled for those regions. There we go. As I said, this is one of many samples, so go check them out. But this is a good way of automating pulling of information from live systems. Let's find where we were. Right. Drew, shall I hand over to you?
Yeah, sounds good. Just got to find the buttons.
Sure.
I have chucked the links to that sample that Andrew's just run as well. So if you do want to go check those out, have a look in the chat, and hopefully start sharing. Okay, hopefully you can see my slides. Yeah, so Andrew's just done a great overview of what Ansible is and some of the content that we've had out in the CICS collection, which we both work on. We've had that CMCI content out for about, I think it's coming up to 4 years actually now. So it's been around for a while now. Had some good user testing, been around a while, had some good results from it. So some of the new stuff that we released back in June last year, we released all these modules here. I won't give you too many guesses to what each of those modules is probably doing, as they've got some quite descriptive names. But basically, the new content we released is focused around provisioning different CICS regions, whether that's multiple regions with shared CSD or just singular regions by themselves. So no CICS but just single regions essentially. I've got a couple of other modules there for creating some startup JCL for the regions and another one for stopping regions as well. So a couple of automated actions as well as creating CICS-specific data sets was the main focus of this content. And this was all released in 2.1.0. So any earlier releases than that was purely CMCI content. With this new version of the CICS collection release, we have both the provisioning content and the CMCI content in the same collection alongside each other. So you can interchangeably use both. So for example, if you could provision a new region, add some CSD resources, and then even if that region has CMCI enabled through SMSS or SMSSJ, you could then use the CMCI collection on top to interact with the region as well. quick point about the version number, just in case you have seen the CICS collection before. We did do a major bump around, I think it was May last year, where we deprecated Python 2 support. So on the controller, so for our demos, that's mine and Andrew's laptop or AAP, but that could be a build system. It could be quite a few different things. It's basically not ZOS is the best way of describing it. On that platform, we've dropped support for Python 2. We've also introduced a new dependency purely for the provisioning content. So this doesn't affect the CMCI content, but just the provisioning content, the new stuff. We now have a dependency on IBM ZOS Core and ZOAU, or so ZOAU and Python for ZOS actually on the ZOS target node. Little bit about that. With the latest version of ZOS as well, that's now introduced as a no-cost license. So yeah, it makes it a lot easier to get for customers. So I'll definitely check out this announcement if you haven't seen it. I think this came out quite a few months back. But yes, so all these new modules now have that dependency on Python for ZOS, and Z Open Automation Utilities is in the documentation site. So if you have a look at installing this, if you want to use this, it's fully docked there, which versions you need, which compatibility you need, and what we support at the moment. So yeah, I'll definitely take a look at that if you're interested in using these. So I think I'm going to jump into the CSD module as a good example of one of these dataset modules. So lots of these dataset modules, which are the quite a few of these, like aux10, aux-trace, CSD, global catalog, local catalogs, local request queue, TD partitions, transaction dumps. They're all around creating CICS datasets. So we'll look at the CSD one, but lots of these, lots of things I'm about to show you apply across all of them at once. So just bear that in mind as I do the demo. Make this a lot bigger. Okay, hopefully you can see that okay. So yeah, similar to Andrew's playbooks previously, we have one here. I've called it csd.yml. Pretty simple. Giving it a name at the top to talk about provision CICS datasets. I'm going to remove that end because that doesn't actually happen. But yeah, all this is doing is a singular task to come along and create a new CICS dataset at this DSN. We have a few parameters under this CSD task. So as Andrew previously explained, this is a CICS This is a collection, so an Ansible collection. This is actually the CICS collection, and then the .csd is a module within the CICS collection. So this is a shippable installable unit of Ansible, and then this is just one of the things inside that shippable unit. So yeah, just a CSD module. So all this does will go along, create me a new initial CSD. So that doesn't mean just an empty vSAN dataset. That means we've come along, we've created a vSAN dataset with the right attributes to be a CSD, but also runs a CICS program to initialize that CSD to make it ready for use with a CICS region. Let's go ahead and run it. Turn off all the verbosity because I don't need that. Actually, I'm going to stick one on actually because I want to show the output. So yeah, with the Ansible playbook commands, if you stick something, these -v's at the end are verbosity levels. Really useful for debugging and just for seeing what's actually going on your host. Because you're running code remotely over an SSH connection, right? So if anything goes wrong, it's really easy to see debug login if you're running this with a higher verbosity. So we normally recommend not running it with at least 1v, for example. Again, just like Andrew, I'm running this over this inventory, so exactly the same LPAR actually, I think, just different username for my user. So yeah, that took a little bit more time than the CMCI collections because we've got to do a few more different things. But yeah, we've gone ahead and we should have created a CICS 6.1 CSD because that's based on this SDFH load, which is a path on my managed nodes on my ZOS machine. That should be an actual dataset. And it must be, otherwise this wouldn't have worked. But yeah, we get this big, long yellow output here. I'm not going to go into this because if you're familiar with CICS, you'll probably recognize what this is. But basically, we create this consistent output across all the dataset modules. where we have this big list of executions. So these are 2 items in it. One of them's massive, so it's taking up all my terminal space. Other one's a bit smaller. But basically, we go ahead and run quite a few different actions on the managed nodes. So we use a program called, well, we use the IDCAMS program to create the vSAN dataset. We then run a CICS program called DFH CSD UP, which gave all this output to initialize the CSD. And then we go ahead and do some checks using TSO commands just to check that the dataset has been actually created and is there. Otherwise, yeah, something's gone wrong. And we also return these nice, we should have an end state as well right at the top. But yeah, we have start states and end states. So you can code against these to make sure that each task in your playbook succeeds before you then go and do another task. So for example, I could have another task here like, I'm gonna have to actually get this right off the top of my head. Yeah, let's just do output result or something. And then we can use that nice Ansible built-in, one of those nice built-in tasks. There's one called debug, which is really handy. It gives you a message, and then in here we can go. Oh yeah, let's actually save this. So, was it register? Yeah, here we go. There we go. So we can take this variable here, result, and then we can chuck that into a debug like this. And then that will pretty much do the same thing as having the dash v, where it will just output that return structure. Take a second. Oh yeah, we should probably also mention Ansible has this thing called idempotency, which basically means you can continuously run this thing with a desired state. So our desired state here is initial. It could have been absent to delete the data sets, but basically the playbooks are repeatable. So if you run them twice, you should get the same output. Nothing. So you would expect something to not change necessarily if your data set's already in the state that we are trying to achieve. CSD is a little bit of a weird one where we do a couple of actions even if it does already exist. So we won't see this change not be true. But for something as simple as a simple file or a simple data set, you should be able to run a task twice and first see it changed and then see it second not changed because nothing's actually happened because Ansible didn't need to actually do anything. But yeah, you can see I've got this output this time and I should be able to just access one of them by just doing something like be something like result and then in the, because it's a Python dictionary, you should be able to just do something like start state, for example, and then you can just access just this piece of information. So yeah, really handy, completely built into Ansible. Yeah, let's move on a little bit, talk about a couple of other features. So something else you can do with the CSD module, which is quite cool, is although you can just allocate and create an initial CSD, we also give you the ability to run arbitrary CSD UP commands directly against the CSD. So you can extend that with your own definitions. This one, for example, is adding the terminal definitions supplied in the CICS default list. I've forgotten which one it is anyway. So yeah, you get these by default with your CICS installation, but they're not added to DFH list, so they're not auto-installed for you for your region. So if you did want to use the sample console definitions, you could add them to a list automatically to then just add that to your group list to auto-install them when you start your region. But you could also do other stuff here, like actually define resources, for example. So get out of PowerPoint and go back to VS Code. I go on to CSD part 2. I have done a couple of other changes this time. So yeah, I roughly have the same CSD task here. The only thing I've done this time is I've used a Ginger template to specify the Apple ID. So you can do that inline doing stuff like this. Ginger support is fully built into Python, which is fully built into Ansible, which is really handy. So then I could just have a top level of bars to reference my Apple ID everywhere. And then I've got a inline CSD UP update here where I'm adding those console terminal definitions to this DFH list 1. So I can easily install them by putting them in my group list for my region startup. I've also got a couple of journal model dummy definitions that I've got in here. So these will actually create these definitions. So I can go ahead and run this one in a very similar way. Just change the name of the playbook. So we'll run CSD part 2 this time. Actually, go ahead, create the CSD as the first task. And then the second task, it will go ahead and add these resources to that newly initialized CSD, which means in theory, if you run this twice, what we'll do is we'll create a fresh CSD, then add those definitions. And then if you run it a second time, we'll revert that CSD back to an initial state, then add the definitions again. So you wouldn't end up with duplicate definitions. You would just end up with this state of a CSD with these definitions. So yeah, let's go ahead and run nicely. You can see we've also inlined Ginger directly into the CSD UP scripts, which is really handy for doing stuff like making referencing everything in the same group. So I've got this group up here called my group, and then I'm just adding this group to DFH list 1 as well to simplify the simplify adding this to my group list. Makes it really easy to do stuff like this. It's like previously you would have had to do this with what a JCL template maybe, and having that JCL actually on ZOS. This way, I can have it in an Ansible YAML playbook. I can still template it, but template it probably in a lot easier way. And then check it into a source code management system like Git and do code reviews on it. And store all my infrastructure in one place. Really handy. One thing I will point out, so we did a couple of optimizations within the CICS collection, which are probably worth talking about because they're in all our samples. But you might notice that, for example, CSD in both of these is exactly the same. So that whole region datasets key is the same. CICS datasets key is also the same because I'm pointing to the same CICS install. So what we added support for was this thing called a custom module defaults group. So Ansible has this thing called module defaults, which essentially applies those parameters across all your modules that opt into that defaults group. So what we can do is we can reference the group. I've got to remember off the top of my head. Might actually have to look at the slides. Luckily, I do have them in here. Yeah, there we go. It's group slash. Always get the syntax for this wrong. Yeah, group slash IBM. Yeah, cool. Okay. IBM dot. So you have the reference namespace, reference the collection dot region. And by default, all of our dataset modules opt into this group. The CMCI ones don't. The CMCI ones actually have their own group, which is really handy as well. So you can share all the CMCI parameters across the CMCI group. So this is the region group. And then we can literally just come along, grab these, remove these from here, and paste them over here. And I think that one needs tabbing back. And then again, likewise, I can remove the duplicate definitions from over here. And yeah, simplify my playbook nicely. That's not tabbed right. Okay, it's potentially still running. Interesting. Right, okay. Ansible's smart enough to work out that even with the bad tabbing. Nice. It's handy. Run that again just to make sure. Cool. Anyway, yeah, the only downside to this currently is the Ansible extension is not quite as up to date with the Ansible core features. So this was a new thing in Ansible core 2.15, I believe, which is the lowest end of the supported versions these days, which is good. So any in support version of Ansible, you should be able to use custom module defaults like this if collections have created them for you. And yeah, massively simplifies this. So where that kind of leads us is if we started introducing more data sets, for example, we might also, so if you can think of what are some other data sets we need to create a CICS region. So I'll start with one, an obvious one. You need a CICS global catalog, for example. So let's make the global catalog data set. So again, we have a module for this. Under the CICS collection. So you can actually see all of them here. So let's go ahead, use the global catalog. We'll give it state initial because we want to create an initial global catalog. And what we could do is we can go DFH GCD up here, give it a DSN like that, and we'll give it a very similar DSN, but I'll just change the end because instead of CSD, we'll go GCD for global catalog. And we can go ahead and run this. And this will now use those region datasets, but only the ones that apply to it. So only use this one. It will ignore the CSD one because it doesn't care about the global catalog module. Doesn't need to know where the CSD is. But it will also use the same CICS install to run the global catalog program. So that runs DFH RMUTL to make sure that the global catalog is in a initial state. This you can change this to make a cold start global catalog or a warm global catalog as well. There's a couple more states for the global catalog, and it's a bit more heavy on what those states actually represent because it's quite important to how your CICS region is going to start up. So if you need to do a cold start or a warm start of a region, you can use the state control on the global catalog to change a lot of that information. So yeah, let's go ahead. Created the global catalog, created the CSD, added the resources. Should probably actually prove that it has actually done that. So I open the terminal session quickly and just make that a bit bigger. It's taking this time to log on. There we go. So yeah, I'm going to use a part of ZOAU. So this VLS command is used for listing datasets. It's something built into Z Open Automation Utilities. But so yeah, really handy is what the CICS collection kind of is using under the covers and what the IBM ZOS core collection uses under the covers to actually run all the interactions with ZOS. So it should just be this plus the Apple ID, which is IYK2ZPZ. I think it's 7 this time. I should stick a star on that. There you go. Yeah, cool. So you can see, like, I've got global catalog and a CSD under here. Yeah. So let's switch back. So yeah, we're talking about these tasks, talking about this optimization. So the last optimization we did was, you might notice, if you've ever used the sample CICS programs that come with the CICS install to create region datasets, they all use the same terminology when referring to global catalog datasets or CSD datasets. We always default them as DFH GCD or DFH CSD. And we normally find that customers tend to use these because really lots of people don't actually care where they create what the actual dataset is called. They'll care about the high-level qualifier of where your region is going to be created under, but you don't normally actually care like if it's called DFH GCD or global cat or something like that. It doesn't normally matter to someone. And if you're one of those people, you can use another handy optimization and simply replace this with a custom template we have. So what we'll do is we'll pit them under the same high-level qualifier. So IYK2ZPZ. Oh, well, yeah, here we go. Apple ID. That's about. Actually use the variable, don't use the value. And then this different Ginger. So this is Ginger syntax as well. It's a different form of Ginger syntax to make sure they don't clash with each other. But yeah, we do this where you can just go data set name. Bit lowercase. I think that's right. It's gonna moan at me if it's not. But yeah, yeah, cool. Nice. Yeah, this will go along and auto fill those values. So this is equivalent to using DFH GCD or DFH CSD. Doesn't really actually, it's a nice little optimization. Okay, and the last one we have for CICS datasets as well, which is handy when you need to refer to more datasets within your CICS install. So, for example, if you're talking about your CICS license file, SDFH LIC or, well, LIC, or something like the SDFH auth one, because you need to pit that, you need to use those datasets as well as SDFH loads. Again, we support a template here, which is really handy. So we can simply come along and go like this. Dot. And this one is lib name, I believe. So yeah, and so for SDFH load, that'll get templated at this path dot SDFH load. So yeah, another nice little handy optimization to keep those playbooks really small. So whenever you just refer to datasets, if you just only care about the state of the dataset you're trying to make, if you're just trying to make initial ones or trying to delete ones, you can use this really handy module default script and just refer to them like this. So go back to the slides. Yeah, so I spoke about this templating that we built in. This is all documented really well as well. So if any of that if you did get a bit lost in any of that, or I didn't explain any of that particularly well, check out documentation. We've also got lots of samples that use it, which is the main point. The last module that's a bit different, well, one of the other modules that's a bit different is this region JCL module. So this one actually generates a sample piece of JCL that you can use to actually start up your region. In the sample, we actually go ahead and generate a piece of JCL, add it to a data set, and then submit that data set as a job, which then starts the region. So it's a full create me every single data set I need in my region, and then actually start the thing sample. So it's quite full on, but yeah, you can see in this one we've got those extra CICS data sets like SDFHLIC, but I've also got support for LE data sets as well. And the one that's missing is the CPSM datasets as well. You can specify a high-level qualifier just for your CPSM path as well, which is handy. This one also supports you putting in SIT parameters, which are passed as SIT overrides, so override the values in your SIT table for your region. Job parameters as well for your generated JCL. And yeah, you can use this, again, it's a bit like a dataset module, so it has that state where you can create one with all your JCL content using initial. You can also absent it to delete it if you need to do deprovisioning or cleanup. So yeah, this is a sample of that output of what that generated JCL looks like. It's quite concise, but it has, for example, all your CICS data sets. So if you override any of these paths and you choose to not have these at this path, or maybe you're using a shared CSD, for example, and you have them at a completely different high-level qualifier, when you provide you can provide your high-level qualifier for your CSD without actually creating the CSD. So in your generated JCL, you can refer to a different CSD, use that shared CSD with this region, and it will still generate you the correct JCL. And then you can use that to start your regions. But yeah, using it this way means you no longer have to maintain this JCL at all. You just have to maintain the YAML parameters that go into the JCL. So it's a lot easier to think about it like that. So where your actual changes happening for your input parameters is in the playbook and in the YAML, as opposed to on platform and the actual JCL itself. So a lot easier to manage. And if you make any changes to the input parameters, you can simply just regenerate this JCL and not have to care too much about JCL syntax anymore. You don't have to care about editing JCL on platform. You can just change a playbook and store it in Git. So we have this provisioning sample. It's in a similar place to where those other ones are. So if the CMCI one was under this CMCI directory, we have a provisioning directory here, and we have one called full provision, and then there's a full provision SMSS if you want to make a region with SMSS. So it has CMCI in it, so you can connect to it with CICS Explorer or Zoe, or the Zoe CICS plugin, as I think it's called. But yeah, this one again, quite it's got that module defaults that I tried to explain. It's a reason it's worth going through that, because our samples make use of that everywhere, and they look a bit confusing otherwise the first time. They also use top level vars like this for an Apple ID, for example, which then gets templated into both the region high level qualifier, but also actually down into the generated JCL as well. So it'll end up in the right place in the JCL. And then that very last command is actually doing a submit on the region JCL. So what we go ahead, we use this JSub command, which is another Z Open Automation Utilities command for submitting a piece of JCL as a job. So go ahead and actually submits this generated DFH start JCL dataset, which is the one created by this one. This would then actually start a job on platform, so you could then log onto your region, for example, at that Apple ID. Okay, hopefully that seems all right to everyone. I haven't lost you all. I'm not going to do a demo of this sample. We'll come on to how you can use. We've got an example of that in a minute instead. It's probably a bit of a better one. So the last main thing we wanted to talk to you about today, and was in the title luckily, was Ansible Automation Platform. So in case you haven't heard of this is a thing from Red Hat. Ansible is a project that's mostly, even though it's open source, it's mostly sponsored by Red Hat and mostly worked on by Red Hatters. So Ansible Automation Platform is their Ansible as a service offering. It allows you to run Ansible playbooks from a hosted environment, not on laptops, for example, and gives you the extra enterprise features that you need to be able to run this as a actual enterprise strategy across your organization. So you could use this instance, for example, to manage both off-platform x86 hosts, but also your z/OS hosts, all in the same way with the same access controls, the same functional identities, functional credentials to access and run automation against the machines, and also store your playbooks in a Git SCM and pull those in using Ansible Automation Platform. So, for example, you could have all your playbooks actually stored in something like GitHub, whether that's an enterprise edition or even public GitHub, and then pull that content into actual Ansible Automation Platform, run it in an automated manner using timers, triggers, all sorts of different ways. So yeah, I'll come to that scenario in a second. Actually, I'll give you a quick tour of AAP. So we have an instance, and we maintain an instance for our team that we use mostly for demos, but also just play around on and do some of our own automation as well. Here, so this is actually hosted on a OpenShift cluster. If you've ever heard of OpenShift, if you haven't, don't worry, I won't explain it. it's a bit more complicated. But on here, we have like a variety of jobs that have been running on the platform, whether they run successfully, what type of jobs they are they source control updates to fetch the latest information from a SCM like GitHub to load over onto AAP? Are they actual playbook runs where we've run a playbook in the same way that we ran a playbook locally? We have these things called job templates, which link over to actual different playbooks. So I think each one of these actually directly corresponds to a playbook. And then you could have a project which you make the templates from, and this would refer to an actual what's it called? An actual Git repository in SCM. So you could have just one repository with about 5 different playbooks in it, for example, and then so you could have 5 different templates to run at different times and just use one project. So quite handy. So yeah, we'll show you a bit of that in a second as we go through this. This whole thing also has role-based access control, so you could set up different users, for example. So you can set up lockdown users that are only allowed to run a couple of pieces of automation, and you can also limit their view to all the different types of things on this platform. So you can stop them looking at any credentials, having any access to any host environment data. So they might not even be able to see a path of where Python is on z/OS, but they still have the ability to go ahead and run a curated piece of automation. So this works really great for that persona split of having a developer that needs, for example, self-service access to region provisioning and needs to be able to spin up a CICS region with their application in it so they can actually run tests against it and make sure that their application works. But then also have a sysadmin who's written all this automation content for them and has fully locked down the access controls so that they can't come along and provision anything they want. They can only provision this exact type of CICS region with these exact type of parameters applied to it, and they can't edit any of that. They can only run a provision or a deprovision, for example. So we do have a bit of an example of that. I think I'm going to pass over to Andrew to show how that roughly works. So yeah, pass over to you to get that going.
Absolutely. So replace. Here we go. Can you see AAP, Drew?
Hang on, I'll stop sharing mine. Do you want to try sharing again?
Start showing mine. There we go.
There you go. Cool.
So AAP, I am playing the developer. So I will log in as our developer, and because of role-based access, and I go to templates, all I see are our 5 templates that we need to run. So let's just go through and kick them off. So I'll launch template number 1. So this is going to build the COBOL source, which looks like this. So we're paying particular attention to this hello world text that is going to be beautifully displayed here. So once we click launch, we get a run through very similar to you saw in our terminals, but we see it on the dashboard instead. So we're creating a data set for the source code and creating it for the load library that we're going to compile into. Copy the source code over, run some JCL to compile it, submit that compilation, and we have built our COBOL from source into a data set. Fantastic. I'm going to go look at that data set in a second, but first things first, I'm going to kick off our provision because it does take a minute or two. So I'll launch that template now. And what that template does, if I go in and look at it, the Apple ID is provided here by my system programmer, so I don't have to change that. I don't have to control that. It's already there. And if I switch to jobs, we should see an active running job. There we go. Any key points here, Drew, that I should touch on?
I think while we're one thing to point out is Andrew's logged in as developer user, which was slightly different to my user. So it might be just worth pointing out going over to like credentials or something. So this is a sample user that we have that's fully locked down to show this split in persona. So this developer user, although is capable of launching those jobs, like I was saying, has no access to anything else. They can't even look where these jobs are running, for example. That's all pre-set up for them. All they have the ability to do is press the run button and that's it. They can't even edit the Apple ID, for example, of that job.
Yeah. And presumably that's configurable. There would be different levels of access for different people. So
yeah, absolutely. Yeah. Yeah. This is a fully locked down user, but if your users, for example, were trusted enough to know what Apple IDs they should be using, you could give that to them, for example, to control. The other quick thing is the playbook that this is running through, which is going through each data set, is actually that sample playbook for the full provision. So it's that full provision with very minor update in it to just add the COBOL load libraries into the DFH RPL for the region. But otherwise, it's about 95% exactly the same as the other demo, as the other sample in the Z Ansible collection sample. Yeah, there you go. We've got a couple, two definitions as well in there. That's about it. Two definitions and something in your DFH RPL.
great. Yeah. So we are creating the CSD and then we are updating it with these two. We're creating a program and our transaction called Drew is fitting because we're both called Andrew. So only fair.
So handy 4-digit name.
Yeah. There we go. So I reload the output and we are good to go. I will, better or for worse, connect to it. That's the Apple ID that was provided for me. And we are in region provisioned at our local time. And if we run that transaction that is installed, hello world, that's the text I said we were looking out for. So that's brilliant. It has worked. Cool. So now, what if I want to make a change and redeploy? So that hello COBOL, hello world, that's the bit we're going to change. So I've checked out this code locally from GitHub, and I want to go through and change this user group. There we go. And I need to update this to the length. So COBOL is happy. I'm going to commit this change. Updating text, commit and push those changes back up to GitHub. They're now pushed. So what we can do is go to our third template, beautifully provided to me, update the app in the region, launch template. So while that's running, we'll go through to the playbook so we can see what it's doing. So the new source code that I've just changed, we are updating that in the source data set. We're then going to run that compile job again to recompile it to the load library. and then we're going to run a new copy on the program so that changes take effect. So that's still running. Once again, if I run Drew, we get hello world. This one's a lot quicker, isn't it?
Slightly quicker.
Slightly quicker. I suppose we could add a step to run the transaction from an operator command and at the bottom of the playbook. But that's perhaps for next time. So we've done a new copy of the program. We've switched back and we will run Drew again. And we get our updated text. So we've changed the source code on my laptop, committed it to GitHub, and we've run our template, and the changes have been reflected in our running region. There are templates here for deprovisioning and cleaning up, but I don't think, unless you feel it's necessary, I don't think we need to go into those.
No, do you want to just show the return results of one of those tasks quickly? So if you went back to the previous job runs, just, yeah, really handy thing with AAP is, as it's more of like an actual service compared to just running the commands on your laptop, you can go ahead, look at previous past runs, but you can also click on, for example, line 8, where we're copying JCL to dataset. You can actually click on that change and then click the JSON tab to see the full output return from that task. So this is the output that the ZOS copy task gave us. So you can programmatically program off this, but you can also look at it and just make sure that everything's run successfully. So yeah, that's one of those ones. Yeah, that'd be the full operator command one as well, showing you exactly the response to doing that operator command.
Yep. Cool. I will click the deprovision, but I don't think we should sit and wait for it unless you think so.
Nah, I think it's done.
Cool. I'll go back to the slides. Cool. Have you done this one, or are we ready to
no,
wrap up and take questions?
Go on, yeah. Let's might as well wrap up, I guess.
Brilliant. Thank you, everybody. I answered a question in chat. I've not seen any more, but do unmute if you're able to.
Yeah, so if you were interested in what we've shown today, that CMCI reporting sample is probably the easiest thing to get started with. It's pretty low requirements. You don't have to set up anything on ZOS. You can connect to it directly from your laptop. Really handy to just go have a look at that. There's a link in the chat to that one if you want to have a look. But yeah.
Great. Any other questions from anyone?
People asking for the recording, but that's...
Yes, so we will have the recording transcript and everything up in probably 2 weeks or less. So you'll be able to get that. And then also make sure that you get the newsletter for the user groups, because we announce meetings, we send out the presentations and the recordings. So make sure you're subscribed to our newsletter. I wanted to just pull up my slides once again, if I can find the share button, ever elusive share button. Here we go. Well, Drew and Andrew, thank you again for presenting. I appreciate the demo and the opportunity for people to learn how to take advantage of this. I'm going to copy the links and notes out of our chat so that they don't get lost, and we'll be able to share those back with you all as well. And we'll make sure those get posted. So before we go today, I wanted to remind all of you that the Arcadi mainframe user survey is available online. You can find it linked over at planetmainframe.com. You don't have to try to follow this this short link here, and I'll make sure you get it in other ways. But we're already on track to having gotten the most responses we've ever seen from the survey. So we definitely want you to help make it the biggest, best survey response we can have. And that will be open for another, I believe, 2 weeks. To connect connect to us, you can check us out on X, Facebook, LinkedIn, and YouTube, where we do post content frequently. Planet Mainframe and the virtual user groups are very active on LinkedIn, so it's a great place. Find resources, connect with other people that were participating in the sessions. And I want to thank our partners again, Broadcom and Data Kinetics, for their continued support of the user groups and these sessions. And with that, please mark your calendars for March 11th. Topic to be determined, to be a surprise to you. But we'll announce that in about 5 weeks when you get the official announcement for our next event. Drew, Andrew, anything else from y'all before we depart today?
Nothing
No.
from me.
No, thanks very much. I'm sure we'll be back.
Yes, definitely. And thank you for participating. Thank you all for joining us today, and you'll have a great rest of the week.